I think it's time for our day two keynote. Julien Vehent, which is going to speak to you about Beyond the Security team. Julien?
Good morning, everyone. Hi. Yes, we've got a microphone. And we've got slides. Fantastic. Day two is starting great already. So my name is Julien Vehent. I work in the Firefox operations team at Mozilla. I manage a team that's responsible for securing the back-end infrastructure of Firefox. Heard of Firefox? It's a browser. It's fairly popular. And it has, most people know Firefox as a client application, it's a browser. But it actually has a massive back-end infrastructure with a lot of web APIs, services, websites, a gigantic build infrastructure to compile the thing and ship updates every 4 to 6 weeks, et cetera, et cetera. So we have to secure this entire environment, and that's what my team does. On my spare time, I'm also the author of a book called Securing DevOps, which talks about DevOps and security, which is somewhat relevant to this conference. And today, what I wanted to do is to, I see a change in the community. A few years ago, if I were to go to a DevSecOps conference, everybody would be talking about techniques, automated testing, integration in CI, all that fun stuff. And yesterday, I heard a lot of people talk about culture, which I think is very interesting. It's a change. We kind of moved away from the pure technical discussions to one where we really focus on how to integrate security into your organization. And I'm glad, because that was missing. When we were only talking about technique, we were missing the cultural piece. And without the cultural piece, you can't do security. So what I want to talk about today, what I thought might be useful to share, is how I built a DevSecOps team at Mozilla in the Cloud Services division starting a little more than 4 years ago. And how we went from a small team of me to a team of a dozen or so people, what we tried, what worked, what didn't, and what I think is going to be important in the next few years. So this story starts a few months ago, and I was reviewing our project investment for a mid-year review of 2019 with my boss. And we looked at where the people in my team were spending their time, what projects were going to deliver more features throughout the second half of the year. And he noted that we were underinvested in infrastructure security and wondered if that was okay. And that gave me pause. I had to think, like, okay, let's go through the security incident of the last year, the projects that the operations team is currently working on, the security audits that we did, how we're doing. I actually pulled up our main metrics dashboard to kind of review the various metrics we have across the infrastructure. And before I could really, load up that information in my head and answer that, yeah, I think we're doing okay in infrastructure security right now. We may want to spend a little bit more time in other areas. Now, what's interesting here is that this is drastically different from my investment from a few years ago, where we were really spending most of our time in infrastructure security. And in fact, most of you probably spend the majority of your time in infrastructure security nowadays. You're probably, especially in traditional infrastructure, if you manage data centers, sorry about that, but if you manage data centers, you're probably spending a lot of time talking about network security and system security and access management and et cetera, et cetera. And we used to do that too. We used to spend a lot of time securing and hardening our AWS accounts. We helped the operations team figure out how to reliably update their systems, revamp secrets management entirely, account management, auditing our security group. All of that stuff used to take a lot of resources from my team. And something interesting happened. Over time, we built up these capabilities and we gave them to the operations team, and they took ownership of them. And they kept running them. The security continued to improve, but effectively, the involvement of the security team was reducing over time. The operations team, which knows best about all things infrastructure, was taking complete ownership of operation security. Effectively, security was going way beyond the security team in the hands of the people who know best to secure this thing. And I think this is a very interesting end result for us, certainly one that I didn't expect a few years ago, where it seemed that everything security was always going to go to the security team. But I have advocated for some time that operations team are effectively the best security teams you can find. Sysadmins are great at security. They really are great at security. Talk to people who do red teaming in their organization. Half the time they get caught by the sysadmins. They're really, really good at it, so you need to capitalize on them. So I want to talk a little bit about how we got there, and obviously it didn't used to be this way. And let's take a step back before we talk about the last few years at Mozilla and go even further than that. And I want to talk about how it used to be a decade and a half ago. And most of you know this, and it would be a painful reminder of how things, or maybe if you're not lucky, how things are in your organization. But I thought it might be interesting. So you may have noticed that I have a little bit of an accent. I grew up in France, in cold and rainy Normandy, not unlike Seattle some days. I studied in the Loire Valley, and I started my career in Paris. My first job as a security engineer was in corporate banking. And all the stereotypes were true. We were taking long lunches, drinking lots of wine, eating lots of cheese, running out of things to do in our 8 or 9 weeks of vacations per year, etc., etc. It was terrible. But what is also true is that the security team was all powerful. In that particular environment, nobody would do anything, even remotely risky, without clearing it with the security team first. So this is how deployment used to work in those environments. You would have developers and engineers who were incredibly smart about their work. And they will design a new application, they will design a new project, they will implement it and test it and go to wait a second, security just noticed your project. And security freaks out. What the heck is this? Who's shipping something and I don't know about it? And they will block the project every single time. They will come and say, how come we haven't done a review of this? We can ship this, we need to look at it, and oh, well, okay, it's just a small API. Oh, it's not that bad. Well, okay, maybe you just need one firewall rule. Oh, you're running that on an existing server? Oh, okay, that's easy then. All right, fine, you can ship. Does that sound familiar to anybody? So, Tanya yesterday talked about shifting left. That's what it is, right? Move your security towards the left side. So you don't realize that something's going out at the deployment phase. So we know it's important to do. The question is, how do you do it? In those environments, back in the day, you had to talk to security for everything. I remember helping developers open firewall rules between 2 points. And security had to be involved, and then there were 3 layers of project managers, and the sysadmins had to reference every single action in 2 different web applications for tracking. It was terrifying. And you couldn't do a thing without talking to security. Not too long ago, I was talking to a developer in a definitely non-DevOps organization that was saying that his security team had tight control of the web application firewall. That was the only way they could do security, because they didn't trust their devs. So obviously that doesn't work. It has 2 major downsides. First of all, you slow everything down. You put security in the blocking mode, you slow every single project down. We yesterday in the panel mentioned the 100-to-1 ratio. For 100 developers, you have 1 security engineer. You can't have your security engineer be the bottleneck. That's impossible. You're just going to grind everything to a halt. And secondly, and probably the more dangerous of the two, because you could always staff your security team to have 100 people, and then you wouldn't have a bottleneck problem. But when you remove the security dimensions from the work of developer and operator, they absolve themselves from it entirely. They don't worry about it at all. They will ship their features thinking, I'm not even going to check if I have a SQL injection in there because there's a web application firewall that's going to take care of this for me. And a lot of organizations suffer from this. they suffer from their developers not caring about security, and they think it's because the developers are bad, but perhaps it's because the security team is not telling them they need to care and helping them care about it. So we know this is a bad situation to be in. So one important aspect of changing this is getting closer to developers and operator. And it took me a few years from the mid-2000 to 2012, 2013 to get to that realization that I couldn't do my security work from afar. An interesting thing, perhaps interesting thing about me is that I'm an odd security engineer. What I actually like to do is to build things. I like to build security services. I like to build network services, internet services. I like to put shit on the internet and connect to it from the other side of the globe. That's fun, right? Security is really something I got into later on. And at some point in my career, I was running a website affiliated with Who Wants to Be a Millionaire. That was really one of the high points of my career. I was just so proud of that one. It's fantastic. I remember telling my mom about it. It was bad. Anyways, so Who Wants to Be a Millionaire would air a question every day. And they would point people to our website where they could answer the question, gain a few points, and spend those points buying shit that they don't need. And we would make money. Now, this was a small operation, and it was running off a single Java web application hosted on a single server that I upgraded to like something with a couple of hosts behind the load balancer and a big database. And every day they would air the question, and I would look at the graphs. I would look at the requests coming, a few hundred, 500, 8,000, 2,000, and inevitably every single day the whole site would go down and fall down and crash completely. But guess what? They didn't care. By the time it crashed, they had already made a bucket load of money. It was cheaper to keep running it this way than to spend a bunch of money on engineering. I mean, sure, ideally, it would have been nice to have something that didn't crash every day, but meh, who cares? It crashed. And the point I'm trying to make here is not that I'm a shitty sysadmin, right? Although that is, depending on who you talk to, that may be true. The point I'm trying to make is that serving the business was actually more important than doing perfect security or doing perfect infrastructure in this case. This is an extreme example. Don't follow it. But it was an interesting lesson. About 4 years ago, I decided to join a small group of engineers at Mozilla who was working on really redefining the way we build cloud services for Firefox. And they were adopting all of the fancy, shiny new things. Immutable deployments, CI/CD, containerized applications, etc., etc. You could audit the entire infrastructure without touching a single server. We were playing with the idea of removing SSH completely from our production system, etc. So this was all super interesting to me, but it was also scary, right? Because I came to this with my mental model of security from the infrastructure mindset, where you must have an IDS and control all of the outbound connection, etc. And AWS was the enemy, and DevOps was just this thing everybody was laughing at in the security team. So this was really like this is a trend of DevSecOps, the DevSecOps keyword on Google, right? In 2015, when like people are like slowly, starting to talk about it, but no one's really taking it seriously. And so what was interesting to me is that I'm not an early adopter, right? My notion of learning new things is these days is picking up woodworking and learning joinery, right? And by the way, those joineries on the beams here with all metal things, that's, I don't know, I don't trust that thing. But anyways, the point is, this was kind of a leap of faith to me. Let's go see what this team is doing, how they're operating differently. And another interesting thing is that this group had no security team. The reason I was going is because the manager of that team knew he needed security, didn't want to rely on external security teams that weren't fully aware of what they were trying to do and wanted someone in-house, like really inside the team. So this is kind of how I felt joining the team. I'm the security engineer, and I'm walking into the lion's den, surrounded by sysadmins who spend their entire career distrusting security. And you may feel this way in a few situations in your own organizations where you don't really feel invited. You're sitting in those meetings and like, well, I guess they didn't really expect me. Sometimes they tell you, oh, you're here. And so security people usually see the sysadmins as the enemy. They're the ones who don't update the servers. They're the ones who don't care about using weak passwords. They're the ones who leave the networks wide open to the internet. They're the ones who don't do what we tell them to do. They fail at implementing all these security things we tell them to care about. They're the enemy. And to be fair, they see us the same way. We're like Sauron in the tower, like in the big eye, seeing everything, looking at every aspect of their work, then going to their managers, telling them they fucked up, and telling them they need to fix it now, and then goes down. They hate us, right? So we have this conflictual relationship, be the understatement here. And there I am, a security guy joining an operations team. Now, not joining like literally in the operations team, reporting to the same people. So this was an interesting situation for me to be in. And I realized I couldn't come to this with my usual approach to security, which you just barge in with a bunch of controls and spread them across all the projects, say you have to do all of this, and then move back and go back to do my own thing. I had to win them over, right? So I needed something to show them that they could trust me. Thankfully, one of the senior member of that team messed up shortly before I joined the team, actually, and pushed. That's not him. I don't think he skateboard, actually. Great engineer, fantastic engineer, someone who has tons and tons of experience, and I love working with him still today. And he pushed a version of the secrets repository that wasn't encrypted at the time up to another GitHub repo where it wasn't supposed to be at all, effectively leaking the secrets of the infrastructure out. And he did this with, with the confidence of someone who has run these commands hundreds and hundreds of times over the years, right? So thankfully, that didn't end up being too bad because the GitHub repo was private, but still it was a pretty strong wake-up call that secret management wasn't up to par. So we had to fix it, right? And this was a perfect project for me because I happened to know a few things about security. And so we decided to put that on the table and start looking at how we could improve secrets management in the organization. And now my typical approach to doing this at the time was, all right, build a tool, a fantastic new tool that's going to be beautiful and great, and then shove that into the operation team and spend weeks convincing everybody until they either convince or cave or their boss tells them to get along with it. But not here. I couldn't do that here. Mostly because most of our approaches at the time didn't work. Where at the time you would encrypt a file with GPG and you would decrypt it with GPG, which by the way is terrible. Don't use GPG, please. That's another talk. But the problem with that is that you need to put your GPG decryption key on the server, and we're talking about AWS instances that are in auto-scaling mode. Obviously, that doesn't work, right? So you have the bootstrapping of trust problem, which nowadays is well understood and fixed. We have talks about secret management this afternoon. You can look at a dozen or so projects that do this properly, but we had to figure out how to integrate that into our new provisioning and deployment models. So instead of building a tool and just shoving it onto the team, we started iterating on the model together. And we came up with the first, a tool like Blackbox. Can we use this? And then started iterating on it. All right, well, maybe we need something to have encrypted secret in S3. The EC2 instance retrieves them, etc. The ops team came along and said, well, we need versioning. So we need to be able to deploy stacks by version, roll them back by versions, because that's how we do continuous deployment, etc. And we kept working on this together until we got to a model that made sense to us, where we really could see that fit into the deployment pipeline nicely. Now, what's interesting here is that by the time we reached the fourth proposal, I didn't have to sell the operations team on it anymore. They had shaped the design, they had shaped the goals, they actually wanted the thing. Now the trick is that I hadn't written a single line of code by that point, so there was a chance I wouldn't be able to do this, but that was a risk I was taking. I thought it was a very interesting experience that we worked together on building a security tool, and to them it was new because they had never worked on building a security tool. Usually security came with their tools telling them to use it. So this project was successful. It turned into an open source project called SOPs, which we still use today. Since I started this talk, we probably already deployed a couple dozen EC2 instances that use SOPs to decrypt their secrets. And I think it's used quite a bit around the community. People like it. It's one of the many secrets management tools. But more importantly, we learned that we shouldn't just build security tools. We should build operational tools that do things security, right? Solve the operational need first and integrate security into that. And that was an interesting shift in mental model for me that I actually continued to apply throughout, building this DevSecOps team. So I was embedded. I was embedded in that operations team for a couple of years, actually until fairly recently when my security group grow beyond the size where being embedded made sense. And what was interesting throughout these years is that I was not just a security expert, I was their security expert. They trusted me. We did security incidents together. We worked on everything together. They would come to me for help. I would come to them to find good solutions to our problems. And I wasn't the external security guy. I was their security guy, right? And that is a very, very powerful thing when you're doing security. Something that we don't capitalize on very much. So I started thinking about this in terms of how we build security teams. And you really have two models in most organizations. The most common one is a centralized model. It's a model where you have a chief security officer that reports to the CEO, and the chief security officer has a security team, right? And the security organization is separate from the engineering groups. The distributed model is basically the opposite. You may have a chief security officer that's up there doing strategy, but the security teams are kind of embedded and belong to the engineering groups. Now, both models have their pros and cons. The centralized one has the benefit of having a strong, opinionated, cohesive security team that can influence the organization. But the downside is that they're far away from the engineering team, so they have usually incomplete information and have to make a lot of assumptions. The distributed model is the opposite. They have good information. They're embedded in the engineering team, so they know what's going on. They can fix it where it happens, but they don't have this large security organization that can probably use its weight to shape the organization or change systemic problems. There's a hybrid model that I really like, that I really believe in. It's the embedded model. And the embedded model is one that you see in a lot of more modern, more DevOps organization, where you do have that security organization reports to your sites or reports to the CEO, but the security engineers are embedded into the engineering groups. Now, what embedded means here is very, very important. We're not just talking about some security guy who attends a meeting and every once in a while has an opinion about something. We're talking about security engineer who half belong to those engineering teams, as in if the engineering manager of group A or group B needs security work done, they ask their own embedded security engineer, and they can influence their priorities. They have control over what they work on. It's basically a consultant, right? They control their work. So one of the main problems you'll see in a lot of organizations is that you have embedded engineers, but every time the engineering managers will ask, can you do X for me? The engineers will say, well, I'm sorry, that's not my priorities for this quarter, right? So what's the point of being embedded if you can't help? So here, what's really important is this aspect that when you plan the resources of your security organization, make sure you allocate 30 or 50% of time that's under the control of the team they're embedded in. And those problems will come because you won't be able to account for that time in advance. You'll have to do it on the fly. Another aspect that is very, very important, and we talked about this a little bit yesterday, is security champion, which is basically reverse embedding. You take engineers from the organization, you bring them into your security organization. Now, the way you do that is very important. You can't just snap a security champion sticker on a bunch of developers and say, right, now your job is to make sure security is done properly everywhere, because that's bullshit. You need to invest in them. You need to help them grow. The first thing you need to do is to make your security organization transparent, to allow them to attend the meetings where the decisions are taken, to allow them to shape the security strategy. There's no reason there should be a closed meeting where they can't attend, unless it's a particularly sensitive security incident. Okay, fine. But if it's just your regular team meeting or your regular project meeting, let the security champions join in. Let them chip in. Let them learn, shape the decisions, etc. Run an open organization. Now, what you really want to get out of these models is to avoid making assumptions, to get enough information that every single decision you make is based on really good hard data and not assumptions. When I first joined Mozilla, I was working on this project. In the panel yesterday, they asked, like, do you have any regrets? This is mine. I spent 2 years working on Endpoint Security. Super cool project, completely greenfield, implemented in Go, new language, fancy stuff. You could run a command and it would go inspect thousands of servers within seconds and return to you that a string is in a file on that server on the other side of the infrastructure. It was super cool and not very useful. And the reason for that is that we had super fancy modules. I think the one that's on the demo here is a file module, and it looks for a private key in /home across all the servers. Well, it's a subset of servers. And it will return the servers that have a private key in /home, right? That was a way for us to find servers that had bad things. And all of those fancy modules, to look for strings in memory, to et cetera, we never used them. The way we used MIG was as an inventory tool. We used MIG to list the servers we had running that possibly were accessible from the internet or running on a given version of an operating system or had a given package. We needed an inventory, and MIG was the right tool to give us that data because we didn't have any other. But this was pre-cloud. This was before you could query your entire everything from an API. Really what we were trying to do here, we were trying to, and by the way, it was called Mozilla Investigator, and the logo was a gator. Get it? It's just, what we're trying to do was removing assumptions. It's not something that's specific to the security industry. The New York Times wrote a fantastic article on what failed on the 737 MAX. And at the core of it, and they said, and I quote, after Boeing removed one of the sensors from an automated flight system, the jet's designers and regulators still proceeded as if there would be two. They made the assumption there would be two sensors. They had bad information. Every organization failed in a way, hopefully not with the kind of dramatic consequences that happened to Boeing. But personally, I fucked up too. This is a post-mortem report. You may, if you use Firefox, you may have noticed about 4 months ago, we had a little bit of a blip, and you couldn't load add-ons for like a couple of days, right? In the post-mortem, our CTO wrote, the team responsible for the system which generated the signatures knew that the certificate was expiring, but thought incorrectly that Firefox ignored the expiration dates. The team responsible. Hi. I made an assumption 2 years ago when I issued that certificate that Firefox would ignore the signatures. I didn't test that assumption. This is what happened. We blew up a product for a few 100 million users. Test your assumptions. If there's one thing you should get out of this talk, is that you should test your assumptions, always. Now, when Firefox blew up, I was on parental leave, traveling the country. I got a phone call. I was in Page, Arizona. I barely had internet. I sat at this table by the campsite where I could get some internet from like 9 p.m. to 5 a.m. Now, it was warm during the day, but in Page, Arizona, it's like 35 degrees at night. I wasn't wearing shoes. I got sick for 3 days. Anyways, like, this is what happens when you make assumptions. You end up in a bad situation trying to fix a security incident with hundreds of people and poor internet. Don't make assumptions. Assumptions lead to vulnerability. Remember this. It is extremely important. Now, thankfully, there's a cure. Data. You need to have data. You need to have very, very good data. You need to expose that data, give that data to everybody in your organization, let them look at it, let them review it, let them debate it, maybe disagree with it. Data brings you confidence. Now, the data is only as good as the tool that gives you the data, so you need to trust your tests. You need to have really, really good tests. And here I have an example from one of our testing framework that's called Frost. You can see it at github.com/Mozilla Frost. And it's kind of like it's based on PyTests, and we run a bunch of tests for AWS, GCP, Heroku, et cetera, et cetera. And this test, I think, is interesting because it is a test that verifies that our EC2 instances run on AMIs that are up to date. And now, the definition of that test, initially, as we came up with it, was wrong. It was flagging everything as insecure. And we iterated on it with the operations team to understand exactly what the test should be, what the compliance level should be. What does it mean to run on an AMI we consider secure? One of the things we changed is that we only accept AMIs that are owned by us, that are hosted in one of our accounts. Another thing is that we decided that the AMI had to be no older than a configured date, right? And these two things together were actually discussed, debated with the operation team until we reached a point where we thought, yeah, this makes a lot of sense. Let's put that in the test, run it, and get some data out of it. Again, we didn't just shove that test and the metrics that go with it onto the operations team. We built it together. So that feeds into a very important point. When you do security in your organization, you need to make it very, very clear with everyone involved what you believe the expectations are from a security perspective. No surprises. Nobody likes surprises. Nobody likes that graph when they try to ship something to production and only realize that, in fact, they're missing a bunch of security stuff that the security team really, really wants and nobody told them about. That's terrible. So you need to set clear expectations. Now, we tried a few things over the years. This is Simon Bennett. He wrote a blog post about this that was like 2.5 years ago. And Simon works on OWASP ZAP. You may know him for his work on this. And in the team, he's the one who came up with the model of what we call the web security baseline. The web security baseline is a basic set of controls that we want everybody to implement. Now, we thought initially that we could get ZAP integrated into our Jenkins pipeline, and every time something would go to pre-production and then to production, we would test the baseline, and if it didn't pass the baseline, it would actually fail and prevent production deploys. And we built a bunch of tooling, like this is a run of the ZAP container with the baseline, and the upper part is a Circle CI snippet, and the lower part is like what the tool will output. And if you have everything good, you don't have any failure, it exits with a 0, so it passes, and if it has any failure, it would exit with a non-zero code, which would fail the CI. We thought this would be great. We're putting the security reports in front of the devs, they can adopt it, they can make it work. It didn't. And the reason it didn't work is because the test itself was clunky. It didn't integrate well. It didn't work well. It was heavy, it was slow at times. And we would integrate it into a bunch of applications, and over time they will disable it, or it will go away, or like it will fail one time and block a deployment, and that didn't work. And that was an interesting surprise for me, because I talk about test-driven security quite a bit in the book, and I strongly believe that integrating security tests in pipeline is the way to go, but not always. Sometimes it just doesn't work. But we learned something while doing this. We learned that the idea of the baseline, the core of the baseline, was actually very well accepted by the developers. They liked a lot having the expectations in front of them when they started implementing things. So we turned that into a checklist. And we grew that checklist over time. You can see it. It's actually open, github.com, Mozilla Services, websec-check. And it's fairly long. There's a bunch of stuff in it. It really grew over time. It's in Markdown format because we use GitHub a lot. And when we review a project, we'll copy and paste the checklist into an issue of the application. And we will check off the stuff that doesn't apply to that particular app, because obviously they don't do everything we talk about in the checklist. And then we will ask the devs, all right, before you go to prod, could you please go through the checklist and make sure that everything's covered? And something interesting happened. The devs liked it. The product managers and the engineering managers loved it. They had a clear set of expectations. They could think about, reason about before shipping a product to production. And they will actually put the checklist in their own readiness checklist. So before they would ship something to prod, they would actually make sure the checklist was done. Super powerful for us. And another aspect that I think really helped this is that we had a self-assessment tool called observatory.mozilla.org that checks for the same stuff, not all of it, but a bunch of stuff the checklist checks for, and will output a letter grade. Now, there is a very interesting aspect about grading something, is that nobody wants to ship a production service that grades with an F. And when you put that in front of them, particularly at Mozilla, where Observatory is our own tool, it's used well beyond Mozilla, but we don't want to ship a new product or a new website that on our own tool will grade with an F. It's kind of silly. We did it once or twice, we got called out by the community, we don't do it anymore. Everything we ship to production now, last week or 2 weeks ago, we shipped private network.firefox.com, it's pretty cool. The website for that got an A+. I think that's the one I used as an example here, yeah. Self-service really works well. So the lesson here is clear expectations, checklists, self-assessment is how you win. You make it really, really clear, you make it very easy for your devs to assess themselves, they will use it. Now, I have a few more things to say. I'll speed up a bit because I don't want to take over time. But one important thing I want to talk about is not having to say no. And we touched on this a bit. I want to give you my perspective. Make of that, what you want. I have a little one at home. She's just over a year old. It's at the age where they start walking. And from a threat modeling perspective, it's absolutely terrifying. Because she runs around and everything to me looks like a weapon. It's like the spoon, the cat, the dog, don't eat that knife, can you please get off the stairs? Everything looks like a weapon, everything's dangerous, right? And by the way, you can actually buy a bubble wrap baby suit and put a bunch of duct tape around it, and that works, right? But so the point is, what I really, really want to do is to take my baby, put her in a safe place, and say, all right, don't grow up, stay here, you're fine, nothing's going to happen to you. But realistically, that's probably not going to happen. There's a personal hero of mine, Rear Admiral Grace Hopper, fantastic, fantastic woman. And she quoted, actually not, there are debates whether the quote is from her or not, but let's say it's from her. Ships are safe in harbor, but that's not what ships are for. They're useless in harbor. I can't keep my kid in a playpen for the next 20 years. That's not going to work. You can't keep your organization in the playpen for the next 20 years. Now, a lot of security teams paternalize. It's okay to do it when you're a dad, or I guess a mom can paternize as a mom, I suppose. It's not okay to do it when you're a security team. Your organization is not your one-year-old kid. Your organization is made of adults. They take risks, they make decisions. Your job is to inform them. It's not to tell them no. It's to help them make the right decisions, maybe reshape their design. Don't paternalize. That's not your job. So at Mozilla, we do what we call a rapid risk assessment. Sorry for the URL on this. It's a little clunky. I couldn't put the full one. A rapid risk assessment is a 30-minute to 1 hour exercise where we ask the developers what could possibly go wrong with their application. And we've shaped that under the CIA, confidentiality, integrity, availability triad. I like what Zane said yesterday in the panel. Like, we just sit in the back and ask, so how would you attack this? There's another question I like. It's like, what would really happen if the database ends up on Twitter? And you see the wheels turning in the heads of your devs, and then you help them think through it, and you keep pushing for it. That's threat modeling and risk assessment. You inform your organization, you help them grow. The point here is really that your job as a security team and how you succeed in all of these things, and over time how you go from being that traditional security burden to really enabling and growing your organization, is in being strategic. You need to pick specific battles that help your organization grow. I have a few examples, but you have to basically understand what your organization is concerned about. Maybe the latest fad isn't something that you need. Maybe it is. Maybe, I have an example I like. Everybody talks about zero trust. Zero trust everything, put everything on the internet. It's fantastic. Guess what? I put my admin panels behind VPNs. I do zero trust. We have a single sign-on and everything. But the authentication layer keeps breaking every 3 months. So we want defense in depth. So we use a new shiny thing, but we also made a strategic decision that everything that carries a certain amount of weight will also get a VPN, in addition to the shiny thing. That's a strategic decision. Another one is, I think it is very important to allow applications to blow up. You can't prevent everything from exploding ever. So what I prefer to do is to put things in small compartments, where if something blows up, it's not going to take the entire infrastructure with it. And that way you can let people innovate. You can let them take risks without having to worry about everything else. You need to over-communicate the strategic decisions. You need to make sure, again, that your security champions are on board and help shape that they agree with it, that they have a chance to maybe change it a little bit. And ultimately, what you really want to do, if you want to go beyond the security team, is to put your security team a whole lot closer to your organization, up until the point where, hopefully, they don't need us anymore. Thank you very much. I won't have time for questions, but I'll be around, I think, or...
we can do a quick question. Any questions?
Sure.
Can you share how Mozilla is set up at the moment from an org standpoint?
We are mostly a distributed organization at the moment. We do have security leadership at the C-level, but we have security teams that are mostly embedded in various parts of the organization. We're a fairly big organization, 1,200 people, and that seems to work well for us. I do believe that at some point we probably will go back to like an embedded model. I think it's a matter of, well, it depends. Mozilla is weird because we're not quite a corporation, we're more of an incubator, right? So there's like Firefox and then a million other small projects where you can't just take the security team of Firefox and have them cover everything else, right? So that's why like the distributed model seems to work kind of a little bit better for us. But even within Firefox, like I work on Firefox specifically, we're talking about an organization of like over 500 people. There, inside of that group, we operate more on the centralized model, where my team will, for example, cover something like 70, 80 products and services, and people in my team would be embedded in the various teams that cover these products and services, right? So it's a very hybrid model.
If somebody from your team is embedded in a DevOps, SecOps team, share with us what does a day in the life of someone who's security embedded in a DevOps team look like? Are they reading the stories? Does the security elements end up as part of the acceptance criteria? What does shifting left look like in your organization?
So mostly, we're at a state of maturity where the people who in my group spend most of their time engineering new security controls, security features, and the embedding really means that they are consulting with the various engineering teams. So they're close to them, they answer their questions. If a new application comes up, it needs a code review, it needs whatever, then they will pick it up, right? They will tell me, hey, by the way, I'm going to spend 2 days doing X for these guys, and that's how we'll cover it. But we're at a level of maturity where most of our time, like I showed in the first slide, is invested toward engineering security services and security controls and regression tests and all that stuff, and maturing that part. And we don't do a whole lot of whack-a-mole security work. Does that? I can expand on it after if you want.
Okay, thank you everyone. Please give it up for Julien.
Thank you.
Okay, so there's one more session before the break. We have, in this room, we have CI can make dollars from thin air from Sujib. And we also have a workshop starting as well downstairs, and that is a tournament, the Ultimate Secure Coding Throwdown from Brad. And then there'll be a break at approximately 11 after that. So if you want to make your way to the rooms that you want to see the sessions in, and we'll start in a couple of minutes.